Guys, Miss Kelly here. Happy Monday. Hope you guys had a fantastic weekend. We'll do a little check-in tomorrow just to see kind of how your weekend went, how your week went. You have 2 days of school this week before you get a nice long Thanksgiving break here. So we're going to go ahead and get these 5.2 notes done so that we don't have to do any new notes tomorrow. So hopefully this up gave you guys your green 5.2 example sheet. You'll have this in front of you as you go through the notes today. And then I also need your journals open to page 130 if they're not already there. Page 130. So I'll wait just a second here. Now, if you are prepared, congruent polygons. Congruent is a word that we've heard over and over and over and over again this year. So if I were to ask you what congruent meant, hopefully you're thinking in your head, same size. And that's what we're talking about today. Now this chapter focuses primarily on triangles eventually, but we will kind of start off here just talking generalities with congruence. So I'm going to go ahead and put this on full screen now. 5.2, congruent polygons. Now let's go ahead and get started. You have one vocab term on page 130, just one vocab term. So you don't really need to write the first part here. It just says recall that two geometric figures are congruent if and only if a rigid motion. Now rigid motion, that means that the size and shape don't change. So we're talking translations, rotations, reflections, any of those from chapter 4. One of those had to happen to map one shape onto the other. That's why it's congruent, because when you rotate something, the size and shape don't change. A rigid motion maps each part of a figure to a corresponding spot. Okay, so corresponding parts, I tried to simplify this definition a little bit. So you guys are going to go ahead and write down this right here. Okay? Corresponding, I've said this a few times too. Corresponding in math is like a fancy word for matching. So when we talk about corresponding parts of a figure or corresponding parts or positions, we're talking about matching positions, matching spots. And I think that'll make sense in just a minute. Go ahead and write down that asterisk too. The corresponding sides and corresponding angles of congruent figures are congruent. Because again, when you have rigid motion like a translation or reflection or rotation, you're preserving those lengths and angle measures. So again, on page 130, go ahead and get that definition written down. That's in the blue brackets. Don't worry about that first part. And don't put that journal away just yet, because we're going to look at a couple more things in there. So what's coming up next here on the slides is we're going to look at some figures and try and pick out the corresponding angles and corresponding sides that would be congruent to each other. Okay. I'm going to keep going here, and if the sub needs to pause this slide for a second, more than welcome to, but I'm going to keep going for right now. You don't have to write any of this down. Writing a congruent statement. So this is going to be important because you're going to have to do this in just a second. You're always going to list the corresponding vertices in the same order, meaning like your letters need to match up with whatever they're congruent to. And then this is important as well. There's always going to be more than one way to write them, because you have lots of corresponding parts here. So the order of it doesn't necessarily matter as much as are you matching up the letters correctly. So what they've done down here is they've written out all of the corresponding angles and all of the corresponding sides. Now that just simply came from the marks that were given to you, okay? Angle A has one arc on it. Angle D has one arc on it. That means that they're congruent to each other. Side AB has 2 tick marks on it. Side DE has 2 tick marks on it, which is why we list they're congruent to each other. So when you write this congruent statement, it doesn't matter where you start. I always just pick one of the triangles. Let's just say I'm looking at triangle ABC, and you can list it in any order. So I'm going to give you a couple different examples here. I could say triangle ABC. Now, if I'm going to say triangle ABC, I need to match up my letters correctly. A is congruent to D, so D needs to come first from the second triangle. B is congruent to E, so E needs to come second. And C is congruent to F, so F would need to come last. But again, that's not your only option, okay? Let me give you another example. Let's just say in the first triangle I start somewhere different, like I start with B, and I say BCA. And I'm just making that up, it doesn't have to go in a certain order. Okay, let's just say I say BCA. If I'm going to go in that order, then on my other triangle, B is supposed to match up with E, so I need to start with E. C is supposed to match up with F, so I'd go to F next. And A is supposed to match up with D, so I would end with D. So again, the order of the letters doesn't matter. What matters is, are you matching up the correct letters? Okay. So let's go to this next slide. Now I'm on the green sheet. This is the first problem on your green note sheet. So again, if that's not in front of you, go ahead and grab that in front of you. Green note sheet here. I'm going to start off by listing out these congruent angles. So again, you're just looking at the arcs. They didn't give you a congruent statement or anything where you can match up letters, so you're just simply looking at the arcs. So I'm going to start here with angle L. Angle L has one arc on it. And be careful, because your angle sign and the letter L look very similar, so try and make your L a little more like a right angle, and your angle symbol is a little more acute. And then I go to my second triangle, and what angle over there has one arc? Well, that would be angle R. So notice they're not both on the bottom. That's not necessarily what you're looking for. You're looking for the angles that have the same number of arcs. So angle L would be congruent to angle R. Then I'll go to the second arcs. J would be congruent to angle T, because they both have two arcs. And angle K would be congruent to angle S, because they both have three arcs. So you're looking for the number of arcs. That's how you know it's congruent to each other. Okay, same thing with the sides. Now I name sides with two letters. A segment is two letters. So again, I'll start where there's only one tick mark on the first triangle. There's one tick mark on side JK. And I do want to put that segment symbol above, because otherwise it means the length of JK. And which side over here has one tick mark? That would be ST. Now, if I went J to K, okay, this gets really nitpicky, but if I went J to K, I went from two arcs to three arcs. So when I look at this segment here that has one tick mark, I should also go in the order of two arcs to three arcs. So I'm going to say JK is congruent to TS. So if you're thinking, does the order matter? I would say yes. You know J is supposed to match up with T, and you know K is supposed to match up with S. So that's the order you should write in. Then I'll go to two tick marks. KL. Again, that went from three arcs to one arc, so I should go three arcs to one arc, SR. And then finally, LJ went one arc to two arcs, so I'll go one arc to two arcs over here, RT. And you don't have to write those arrows on the side. And so finally, when you write your congruent statement, again, mine might be different than yours. You can write it in any order that you want. Your letters just have to match up with what they're supposed to match up with. So I don't know, I'll go to the first triangle here, and I'll call it triangle LJK. LJK. And when I look at the picture, I go, okay, I literally went one arc, two arcs, three arcs. 1, 2, 3. One arc, two arc, three arcs. So on the other triangle, I have to go one arc, two arcs, three arcs, which would be triangle RST. But again, that is not your only option. I could have said triangle JKL is congruent to triangle STR. TSR is congruent to KJL. And as far as that goes too, if you want to put the RST first instead of the LJK, that doesn't matter either. Just as long as the correct corresponding parts are matching up. Okay, so now we're going to use these corresponding parts to solve for a couple of variables. And I'm trying to rush through these notes because this is actually Friday morning, and I'm trying to get these done before first hour. So if we go here, it says in the diagram, DEFG is congruent to SPQR. Find the value of x. Well, let's find where x is first. Now, I see two spots where x is. I see this, and then I see the 2x minus 4. I'm not going to use the 6y plus x because it has two variables in it. And so until I know what y is, that doesn't really help me out very much. So I'm going to start with the 2x minus 4. Okay, and that is marking side QR. So I need to figure out, first of all, what QR is congruent to on the other figure, because that's what I'm going to know how to set it equal to. QR is the last two letters in this congruent statement over here. So I'm going to go to the first figure and find the last two letters, which would be FG, which tells me that QR would be congruent to FG. Congruent, again, means same size, same, equal, any of the above. So in the past, what we've done when things are congruent is we've set the two things equal. Like when we dealt with vertical angles or like alternate interior and we said they're congruent, we set those measures equal to each other. So when we solve for x here, we're going to take that 2x minus 4 and set it equal to 12. And again, I knew to do that, the 2x minus 4 is labeling the QR, and I knew QR was congruent to FG, so that's why I knew to set it equal to 12. I'm going to add 4 over. I get 2x equals 16, divide by 2, and x equals 8. Okay? So now when it comes to my y, I have that expression 6y plus x with two variables in it, but now that I know what x is, I can take my 8 and actually plug it in for x, but I'll get there in just a second. Let's figure out, first of all, the 6y plus x is marking angle Q. So let's figure out what we need to set it equal to and what Q is congruent to. Here's Q. That's the third letter in. So I'm going to go to my first figure and find the third letter in, which would be F, which tells me Q is congruent to F. F is 68 degrees. So I'm going to take that 6y plus x and set it equal to 68. Now again, I have a variable an equation with two variables in it, which can't happen. Can't get very far. But I know what x is, right? Step 1 told me x was 8. So I'm going to take that 8. I'm going to plug it in for x. So now it looks like 6y plus 8 equals 68. Minus 8 over, I get 6y equals 60. Divide by 6, and I get y equals 10. Okay. All right. So again, recap. You got to figure out what it's congruent to. That's what you know what to set the expression equal to. And if there's two variables involved, that means you just got to solve for one of them before you solve for the other. I'm going to keep going here. Hopefully not too bad yet, and we'll go over this tomorrow. We're not going to learn anything new, so if you have any questions regarding any of this, we can certainly revisit this tomorrow when I'm here. Same kind of thing here. Number 1 says identify all pairs of congruent corresponding parts. So let's go back to that. That's kind of like what we did in the beginning, listing all the congruent angles and all the congruent sides. So when I do this, if there's no markings, okay, when there's no markings, I go straight to the congruent statement, which is this thing right here. Okay, that's your congruent statement. If I'm not given any tick marks or any arcs, I go straight to that, and that's how I pick out what angles are congruent and what sides are congruent. Because I just go in order, right? A is the first letter, C is the first letter. So angle A would be congruent to angle C. And we've done a little bit of this before, actually. B is the second letter, D is the second letter. So angle B would be congruent to angle D. G is the third letter, E is the third letter. So G and E would be congruent. And then finally, the last letters are H and F. So H and F would be congruent. And then I go to my sides, and same thing. But this time, remember, sides are 2 letters, so I just go by 2 letters. AB is the first 2 letters, CD is the first 2 letters. BG is the first 2 letters, or sorry, second 2 letters, DE is the second 2 letters. GH is the last 2 letters, EF is the last 2, and this is the one that sometimes people forget. Well, you have a 4th side in here, so we're forgetting something. Well, then you go to the sandwich letters, as I call them. The first and the last, A and H, would be congruent to first and last, CF. So that's part 1. If it says just list all the pairs of congruent parts, that's all of your angles and all of your sides that are in matching positions, or when you look at your congruent statement like we did. So now again, we're going to use this to find x. So let's look at our picture here and find where x is. And I see x labeled where angle H is, right here. That expression 4x plus 5. So again, when you think about what to set it equal to, well, what did we say H was equal to? H is equal to F. So go to your other picture, find F, which is this angle here, 105 degrees, and that's what you're going to set it equal to. So 4x plus 5 equals 105. And again, all of this came from the congruence statement. H was the last letter, and F was the last letter. So that's how I know they're congruent. And then we'll quickly solve for this. Minus 5. I get 4x equals 100. Hopefully we all know what 100 divided by 4 is. Right? That's like $1 divided by 4, which is like a quarter. So 100 divided by 4 is 25. Okay. All right. Get it there for a second. All right, here we go. We're going to keep going here. These should look familiar to you, right? And this is in the middle of your journal page. Reflexive, symmetric, transitive. These properties have not changed. They just also apply to triangles. So again, reflexive is when something equals itself. So you see here ABC is congruent to ABC when you just have one statement. Symmetric is when you just flip-flop places like the mirror image. So if ABC is congruent to DEF, then you can flip that around. DEF is congruent to ABC, and it won't change the fact that they're congruent to each other. And then transitive, the one we use all the time with the repeated part. If ABC is congruent to DEF and DEF is congruent to JKL, if they're both congruent to DEF, then they're congruent to each other. It's like a smiling face, yay. So ABC would be congruent to JKL. So again, we haven't used them in a while, but we're going to use them this chapter again. But those really haven't changed from what they originally were. We just now apply them to triangles as well. So I'm going to keep going here. I don't think you'll even use that today, except there are some proofs on your worksheet, but I think you can probably give them a shot, and then we'll go over them a little bit tomorrow too. Last little thing here, this third angles theorem. And this should hopefully make sense. What this theorem says is if you have 2 angles of one triangle that are congruent to 2 angles of another triangle, then that third set of angles would also have to be congruent. Okay, if you think about this, if you know angle B is 100 degrees and you know it's congruent to angle E, then angle E would also be 100 degrees. Yeah? If you know angle A is 50 degrees, and you know for a fact, like it's given to you, that angle A is congruent to angle D, then angle D would also be 50 degrees. And so when it comes to this last angle, C and F, well, you guys learned on Friday in section 1 that angles in a triangle have to add up to 180. So if I did 180 minus 100 and minus 50 for both of these triangles, I would get 30 and 30. So again, it should make sense that if you know two angles are congruent, then the third would automatically have to be, dealing with the fact that any kind of triangle has to add up to 180. It all revolves around that. That's the bell. People are going to start coming in, but I locked the door. Whoops. So we're going to use this theorem. Now, what you're seeing here as you look at this picture, and your eyes kind of have to adjust. I know it kind of looks like three different triangles are happening, but that's not really what's happening here. We're trying to look at this angle, or this triangle, ACD, and it's overlapping this triangle, BDC. So it's like they've been pushed over each other. So in other words, if I were to kind of pull them apart, this is sort of, if I could draw, which we know I lack those skills, that's kind of what you're looking at. But what happened is those triangles were just squished over each other and overlapped. So they want us to find measure angle BDC. Well, let's look at the markings that they give us here. We know angle A is congruent to angle B. Okay, so that's like if I were to look at the bottom image of where they're pulled apart, that's what I'm looking at. And I know this angle down here, D, which is like this on my other picture, is congruent to C, which is like that one. Well, again, third angles theorem tells me if I know two sets of angles are congruent, then the third ones automatically have to be. So this angle here, this big one, would need to be congruent to this one. Now, when you look at the overlapping shape, you're looking at this angle and this angle. BDC is the one that we're actually looking for here, which is this one. Okay, question mark. Well, you know this is 30, and you know this is 45, and you were given the fact that these were congruent, so that's 45, and that's also 30. And our third angles theorem tells me that if two of them are congruent, the third ones have to be. So at this point, all I have to do to find that missing angle is take 180 and subtract off what I know. So I'm going to add 45 plus 30. I get 75. 180 minus 75 is 105 degrees. So again, this all stemmed from the fact that if no one ever told me that BDC was congruent to ACD, but I know that if two of the angles are congruent, then the third one automatically has to be. Okay. All right, that's not your homework. So your homework is actually going to be the 5.2 worksheet. This is in your packet. I gave you these packets on Friday. If you weren't here on Friday, I've left all of the extra packets up on the front table, so you can just grab that. Also, if you weren't here on Friday, you missed the 5.11 as well. So tomorrow, I'd like you to try the whole thing. I can tell you all of the proofs. Is this one with proofs now? I can't remember off the top of my head. Let me look. People are trying to get in my room. So 5.2. Oh, there are no proofs. No proofs. Never mind. I must be thinking ahead. Okay. So on your worksheet numbers 1 and 2, you're asked to list all these corresponding parts. I'm talking angles and sides. Angles and sides for 1 and 2. You got to list all of it. That's why I left you so much space. And then you have to list a new congruent statement. So they give you one, but you have to write a different one, different than the one that's already listed. So there's kind of 3 parts to that problem. You have to give me all the corresponding angles that are congruent, all the corresponding sides, and then a new congruent statement. 3 through 6 is all just finding a missing measure. 7 and 8, you're finding the variables x and y. Number 8, you're also finding x and y, so you're kind of finding what it's congruent to and setting it equal to that amount. And then 9 and 10, you're solving for that missing angle 1. 9 and 10, the angle itself is not 1 degree. Hopefully, you would be able to figure that out just by looking at it, but they're asking you to find that missing angle measure. Okay, so then tomorrow when I come back, we'll kind of go over worksheets 1 and 2, go over any questions you have, and then no new notes. Have a wonderful rest of your Monday, and I will see you all when I come back tomorrow. All right, have a good day.